This video is for AP Stats. So if you're in geometry, this video is not for you. Okay, so AP Stats, we took a Chapter 1 test, and this was the breakdown. So if you're trying to figure out, well, what was the commonly missed, this is what I'm calling each question. So you know a lot of the questions were randomized, but I'm going to go in this order. And if you notice, I'm spending a little bit more time on the Mrs. Abby question or the states question. It's out of the 25 students, 19 people missed that, 16 people missed that question. So these were big ones. If you're needing some more help on maybe this question, these three questions, I'll talk about them quickly, but I'm not going to spend a lot of time on it. Okay, so without further ado, at the beginning, that's the first question I'm going to talk about. Okay. So here would have been one way to show this information at the beginning of the school year. And I'm looking for you to jot down some notes about the question. You might want to recopy the question or recopy the question and write the correct answer. So, but one way would have been the survey about their age. That's quantitative. So if you make like a little chart here, one quantitative, gender, that's going to be categorical. Number of years they lived at their current address. Number of years. Okay, so that's quantitative. Their favorite subject in school, so that's math, science, history. Those are categories. Whether they plan to go to college, that's got to be categorical because that's a yes or a no. Okay, so that means I got 3 categorical, 2 quantitative. This is my answer. If you missed this question, make sure you recopy the question, write the answer, and give me some notes on this. Give me some annotation. That's what I'm looking for. Okay, next question. Now you can see I already have some annotations on here, but another way would be, if you missed this question, copy the question down. So kind of pause the video, copy it back down, and let's see how we calculate this number, $3.50. So this one was much more commonly missed, so let's make sure we spend time to think about this. Ms. Atkins picked up 12 items at the grocery store with a mean cost of $3.25. So what you can surmise from this is that she spent a total of $3.25 times 12. Okay? Now, grabbing a calculator, that's $39. So you know she spent a total of $39. You just don't know which item was the most or which item was the least or if every single item. But if you don't know and the mean cost of each item was 12, then you can know for certainty that that would be 39. Think about it this way. If the room was filled with all the students and every student was 17 years old, if all 25 people, that's how many people there are, times everybody is 17 years old, 25 times 17 would be a total of 425. And so if you wanted to find the average age of everyone in the room, you divide by the number of people in the room. And I get back to 17. So that should make sense. If every single person in the room is 17, all 25 people are 17, then the average age of everyone in the room is 17. If we don't know the varying ages of everyone in the room, but we know the average age is 17, and we know there's 25 people in the room, then we at least know that this number has to be the number that all the ages add up to. Okay, I'm hoping that makes sense. The more you calculate mean by hand, the more that will make sense. Okay, so now with that said, I've got my example. That's not this problem, but that was an example. Now with this said, I know she spent $39 at the store. She added an apple pie that cost $6.50. So then she spent another $6.50. So that means she spent a total of $45.50. Okay, so now, and that's what I had jotted off to the side there, $45.50. Well, instead of 12 items now, she's got 13 items, so I can figure out that And again, that's what I've written underneath here. If on average, she spent a total of this and she bought a new item, then in total she definitely spent that amount on all the items, all 13 of the items. So now my last step would be, I need to divide by 13, because instead of 12 items, I have 13. So if you divide by 13, get $3.50, which is why this is my answer. Make sense? If not, make sure you come see me after school. So that's adding one more item and what it does to the mean. Notice since this item was more expensive than a typical item, notice how it increased the mean. Not by a lot, but a little, by another 50 or another 25 cents. Okay, let's look at question number 3. Oh boy, this was a popular one to miss, so let's take a look. The states differ greatly by severe weather. The histogram below shows the distribution of property damage over the period of 50 years. So it says number of states. I'm assuming, but you could count up all these boxes, that there's 50 states. So the median would be the number between, since 50 divided by 2 is 25, the median would fall between the 25 states with lower amounts of damage and the 25 states with upper amount of damage, okay? So you're really looking for the 26th state if you put the states in order from least to greatest in amount of tornado damage. So let's take a look. Right here it looks like there's already 24 people here. 24 states that had an average tornado damage of somewhere between 0 and just under $10 million, okay? So maybe that's Alaska, you know, places that don't have tornadoes very often, just don't have tornadoes. Now, I'm looking for the 26th state. This one goes up to 6, so right about here where I made this line is where the 26th state must be. So I don't know the exact amount, but I know that the 26th state falls somewhere between 10 and just under 20. So the only number that fits the bill there is the number 12. So again, if you missed this question, copy this question down on a piece of paper, pause the video, copy down the picture here, and add some of these notation that you see in orange. Okay, the 26th state is the median. Now you could have also counted up from either side. To find the middle of something, you can count from the top or from the bottom. But do you see how that's going to be more work? It looks like I have 3 states here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So see how the 26th state has to fall in this bar right here. This is where the median is going to lie. Now the mean is different. The mean would be somewhere over here because these high numbers would pull the mean up because this is right skewed data. But we were looking for the mean median number. Cool? Next question. So lots of people did great on this, and this was definitely stumped a handful of people. So let's take a look at the data. Notice it says a graph of young mothers, so go ahead and recopy this if you missed it. The graph of mothers responded to the question, how many times a week do you choose fast food at a dining? Okay, now notice the note here, width is way smaller. We have to be very careful. If we so we've been doing a couple assignments. So one way to kind of help with this, so this is never 1 to 3 times and 4 or more. You could also think of this, so maybe the numbers threw people off, but you could have never, frequently, or all the time. Notice that's basically what they're saying, frequently, every once in a while, or a few times a week, never, a few times a week, or pretty much all the time. Okay, Those are 3 categories that we allowed them to pick, and it's 30. So we should allow for either a bar to go up to 30, but it has to be the same width, and another bar to go up to 60, or dots that go up to 60. And then last, this one looks like it's going to about 10. So if I had to redo this to make it not misleading, what's wrong with the way they presented the information? The way they presented the information. Well, this kind of data should be presented in a pie chart. That's like, no, we can present it this way. The vertical axis should be number of responses, not percentages. It can be either. That can be either. We can add percentages or number of responses. That doesn't matter. This could be 30 people, 60 people, or 10 people. That's still the same as 30%, 10%, or 60%. So remember that this axis can be our frequency or our relative frequency, and that's always okay. We can list it as frequency or relative frequency, otherwise known as percent. Okay. D, that's my correct answer. The reason why the presentation is misleading is notice how they're messing around with the width. And so this is twice as much, 30%, 60 is twice as much. But notice the area of this is far greater than twice as much. It's almost 4 times as big as this little hamburger. So they're trying to make it very obvious, make it look 4 times bigger when in fact it's only double in size. Okay? Check out the next video.